Alright, so this is the review for the Unit 1 exam covering chapters 1 and 2. So number 1, I'm supposed to plot these 2 points, A, which is at negative 2, 5, and B, which is at 4, negative 3. So here's A, negative 2, and up 5 units. 1, 2, 3, 4, 5. There's A. B is at 4, negative 3, so 1, 2, 3, 4 to the right, and down 3. That's B. Now in part A of the problem and part B of the problem, I'm supposed to do different things. So in part A, I'm supposed to find the midpoint of the segment AB. So here's the segment AB. If I had to connect them, I'm going to find the point in the middle. So you can kind of look and see already where that point in the middle is. It looks right about here, but let's do the math and actually make sure. So the midpoint formula to find the point in the middle is you add up all the x's, so x1 plus x2, and you divide by 2. You take the average of the x's, comma, and add up the y's, and you divide by 2. So you take the average of the y's as well. So taking the average finds you the middle. Here, in our case, since A is at negative 2, 5, and B is at 4, negative 3, our x1 is negative 2, our x2 is 4, so those are our x values. Our y1 is 5, and our y2 is negative 3. Okay, so negative 2 plus 4 is positive 2. 5 plus negative 3 is positive 2 as well. And 2 divided by 2 is 1, 1. So the midpoint is at 1, 1. Which we kind of guessed at, because we guessed that the midpoint looked like it was right here. So in fact, the midpoint is 1, 1. Now you may not always be able to guess correctly and look at where the midpoint is. It might be difficult to. So that's why you should always make sure by using the formula where you take the average of the x's and averages of the y's. In part B, I need to find the distance between the 2 points, A and B. So I need the distance formula. The distance formula is D equals, then there's a big old square root, x2 minus x1 squared, plus the quantity y2 minus y1 squared. Okay. So distance equals square root. x2 is my x's, so I subtract the x's, so it's 4 minus negative 2. Be careful about the negatives. This minus is from the equation, the negative is from the point. Squared, y2 is negative 3 minus 5 squared. 4 minus negative 2 is the same thing as 4 plus 2, which is 6. Negative 3 minus 5 is negative 8 squared. Negative 6 squared, or sorry, 6 squared is 36. Negative 8 squared is 64. That's the square root of 100, which is just 10 units. So the distance between those 2 points, A to B, from here to here, that distance, that total length, is 10 units. And number 2, I'm supposed to find the measure of NO, this length, if this whole length, NP, is 31. So let me write that there. This whole length here is 31. Now, some people who don't think about this problem will try to say 2z plus 1 equals 4z. Well, if you look at the picture, this length does not look like it's equal to that length, so that can't be right. So some people were like, okay, let me add those. 2z plus 1 plus 4z, and they know a straight angle makes 180 degrees. But are we really working with angles here? We're working with segments. Segments don't add up to 180 degrees, only angles do. So we shouldn't set it up that way. What we do set up is 2z plus 1, this part, plus that part, 4z, should equal the whole length of 31. We're using the segment addition postulate, where you can add this small piece of the segment plus this piece of the segment should equal the whole length of the segment. So combining like terms, 2z and 4z makes 6z, and there's plus 1 equals 30. Subtract 1. Sorry, it should equal 31, I'm sorry. Subtract 1, 6z equals 30 now, and divide by 6, z is equal to 5. I go back and read the problem because I want to know if I can stop there. It says find the measure of NO. I found what z is equal to, so I didn't actually complete the problem yet. I need to find NO. So I'm going to substitute. NO is 2z plus 1. Z was equal to 5, so 2 times 5 plus 1. The length of NO is 11. That's my answer. In number 3, I'm supposed to find the measure of angle XYZ. So that angle is this one right here. You need to find the total measure of that angle. Given that YW is an angle bisector. So a bisector means you cut something in half. So an angle bisector means something that cuts an angle in half into 2 equal parts. So this goes right down the middle, creating 2 equal portions. So I know now that 8x minus 2 should have to equal 4x plus 14 because YW, ray YW, is an angle bisector. These two are equal parts. So then solving this by subtracting 4x from both sides, adding 2 to both sides of the equal sign, 4x equals 16, and dividing by 4, I get x equals 4. Again, I check the directions to see if I'm done. They say to find the measure of angle XYZ, so I need to find the measure of those angles. So I need to substitute here. So 8 times 4 minus 2 is equal to 30 degrees. Since this angle got bisected, this is also 30 degrees. And they have me find the measure of angle XYZ, which is the whole angle. This is 30 and 30, so the whole angle is 60 degrees. Number 4 is a construction. I'm supposed to explain how to cut this line segment, KL, into fourths. And then I'm supposed to construct a line segment RQ that's a fourth of the length of KL. So explaining how to cut it in fourths, well, what I can do is bisect KL. So that'll give me, it'll cut it in halves, right? So in halves, there should be 2 pieces. And then if I bisect it again, it'll give me fourths. So it'll give me 1, 2, 3 fourths. I'll show you what I mean in the picture or in the construction. So I need to bisect the segment. So I'm going to start by putting my compass at L. I make sure my compass is open more than half the length, half the distance across, and I'll make a huge sweeping half circle like this. I'm going to do the same on this other side. I'm going to put the compass down at K, and then make a huge sweeping half circle. Notice how there are points of intersection above and below the line. That's key, so that you know that's what you're connecting. You make sure your arcs intersect above and below. Use a straight edge to connect them. So right now I've cut this into 2 equal portions, into halves. I need fourths. So I need to be on each side and bisect each side. Again, put the stabby point on L, and I'm going to do an arc here. And an arc there. Again, make sure you intersect above and below your line to connect them. So I can do it on this side as well. So again, an arc and another arc. So you can see that these little segments are all equal. And they're 4 equal parts. So I cut that line segment into 4ths. I was supposed to construct a line segment RQ so that it's 1/4 the length of KL. So I can pick any of these things, lengths, to be R and Q. So I'll call this R, and I'll call this Q. I can't use the endpoints because they already have a letter attached to them. I can't just name this Q and be like, that's R and Q. So I have to use one of these. So there's RQ. So number 5, what's an essential step when copying an angle using compass and protractor only? Well, I don't know if there's one essential step. I feel like all of them are essential. But so the first step is to go ahead and just start off with a ray. So here's my ray. I'm going to have it go to the right. It's just to label this new angle ROP that I get by copied. So we'll get there later. So the next step is to make an arc going from the vertex of the angle that intersects the angle in its 2 legs. So I need to do the same thing down here at this endpoint. I need to create the same arc, just like that. I'm going to go ahead and measure the opening here, so I have to adjust my compass. So, sorry, it only opens to that much, the size between this arc and that arc. And I use that to make a mark there. I'm going to connect that. And there I created the same angle. I copied it. So I'm supposed to label this R, OP. So here's R. This has to be O. And this is P. And then the next thing said bisect it. Okay. So the steps in bisecting this angle are here. I already have this arc right here that I made, so that's already done. That's the first step in bisecting. I'm going to go ahead into this point of intersection R and make an arc on the inside. Go to point P, make an arc on the inside. So then I'm going to create a ray. So there, I bisected that angle. These arcs right here are equal to each other, whatever angle measures they are. Okay. So number 6, I'm going to plot these 3 points, and then we're going to do a bunch of stuff with it. So let's plot them. 0, 2 is right here. That's A. 3, 6. That's B. And 7, 2. 1, 2, 3, 4, 5, 6, 7, 2 is C. They would form a triangle. So I need to find the perimeter. So if I'm going to find the perimeter, I need to find all of these lengths. Okay, I need to find the 3 lengths. AC, I need to find that length. I need to find the length on AB, and I need to find the length on BC. So the perimeter of a shape is the lengths on the outside all added up. I chose AC first because that's the easiest, because it's in a horizontal line. And to figure out the length on that horizontal line, I am allowed to count. So 1, 2, 3, 4, 5, 6, 7. AC is equal to 7, and I don't have to do any work. AB, though, is at a diagonal. It's like that. It's not straight up and down, and it's not going left to right. It's at a diagonal, so I need to actually find that distance. And the way I find that distance is that, again, I'm going to use the distance formula. Okay. But I'm going to use it between A and B. So between A and B, x2 minus x1, if I subtract the x's, that's 3 minus 0 squared. y2 minus y1, 6 minus 2 squared. 3 minus 0 is 3. 6 minus 2 is 4. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And so that length is equal to 5. So here's the length of 7 on the bottom. This is the length of 5 on the side. Now I need the other side. I need to find what BC is equal to. Again, I'm going to use the distance formula. But this time I'm going to use it between these 2 points, B and C. So B, so again, square root x2 minus x1, so 7 minus 3 squared. y2 minus y1, so 2 minus 6 squared. This is 4 squared, this is negative 4 squared. So this is 16 plus 16, and that's 32. Now 32 doesn't have a nice square root, just like 25, so I need to calculate that and get a decimal. So the square root of 32 is, I need a decimal, so 5.6568. I'm going to go ahead and call that approximately 5.7. So to find the perimeter, I add up all the sides. I do 7, which is the length of AC, plus 5, which is the length of AB, plus 5.7, which is the length of BC. So that perimeter is 17.7 units. Lastly, I'm supposed to determine the area, and that shape is a triangle. So the area of a triangle is base times height divided by 2. Or the area of a triangle is 1/2 base times height. Or like I said, base times height divided by 2. Both of those are the same formula. The base and height on a triangle need to be perpendicular to each other. So this is 5.7. I'm going to use AC as the base because it's flat and it's straight to me. Now the temptation for the height is to use either 5 or 5.7. That's not the height. I need it to be perpendicular to this length AC. So here's the length that's actually perpendicular. So counting 1, 2, 3, 4, that's our height. Back to our formula. Our base was 7. Our height was 4 divided by 2. And it's 28 divided by 2, which is 14. And units squared is our area. So perimeter is the distance around. Area is how much space is inside. Perimeter, I add up all the sides. Area, I need to use the formula. Base times height divided by 2 if I'm working with triangles. Okay. So number 7, I'm supposed to determine from this picture whether these statements are true or not. Okay. So AOB, this angle right here, and angle DOF are vertical angles. This is false. Vertical angles are formed when you have two lines that intersect each other, and they're angles that are crossing each other like that. So those are vertical angles, and these are vertical angles, left and right. This was not a these weren't vertical angles because it formed kind of this shape. They weren't straight line. They weren't two lines intersecting, or 3. So here's one line, there's the other, and it went like this. To be vertical angles, you need to make a shape like this. So AOB would be vertical to DOE. Those are vertical angles, not DOF. Points A, O, and D are collinear. Collinear means on the same line. So A, O, D are all on the same line. So that is true. BOC and COD are complementary, meaning they add up to equal 90 degrees. So let's check that out. BOC, which is this angle, and COD, which is that angle, they sure look like they do form a right angle, but we do not know for sure unless there's a little square box to inform us that that is exactly 90 degrees. So I'm going to say that we cannot determine if it's true or not, so I'm just going to go with false. That you cannot determine if they are complementary. So a pair of opposite rays are OE and OA. So opposite rays are rays that have the same endpoint. Endpoint is an unfortunate word. I would say start point. So OA is that way, OE is that way. So that part's true. They do have the same endpoint, but they also need to go in opposite directions to form a line. So OA is this way, OE is that way. Those aren't opposite rays. If I said OA this way and ray OD, then yes, they would be opposite rays because they start at the same endpoint and go in opposite directions. AOF, angle AOF, and angle FOD form a linear pair. Well, a linear pair just looks like this. There's two angles that form a line. Two adjacent angles that form a line. So let's see if they form a line together. AOF is this angle right here. FOD is this angle right here. And it does look like this picture. So those two angles do form a line. They do form 180 degrees. And so that is true. So number 8, I'm supposed to determine if the following statements are true. If false, provide a counterexample. So a counterexample is an example or a situation, whatever, that proves the conjecture wrong. I'll prove the statement false. So the first statement is if you are in Brazil, then you are in South America. From my geography, Brazil, the country of Brazil, is all located in South America. So if you are in Brazil, it's 100% true that you have to be in South America. So that's true. There is no counterexample because this is 100% true. Part B is this: if an angle is acute, then it is 50 degrees. That's definitely not true. This is false. If you are acute, you do not have to be exactly equal to 50 degrees. So a counterexample would be any example of an acute angle that's not 50 degrees. So here's an acute angle. Call that angle A, and let's just pretend that it is 40 degrees. So it's definitely not 50. So this is a counterexample. It's an example that will prove that situation false. Number 9, I'm supposed to determine if the following statements are biconditional. Like I can write them as a biconditional. If so, write them with an if and only if statement. That's how you write biconditionals. So to be a biconditional, you need to be true forwards and backwards. The statement needs to be true and its converse needs to be true. So if two angles are vertical, then they are congruent. So if you have these angles are vertical, then it's congruent. That part is true. Okay. We have to check to see if the converse is true. If two angles are congruent, then they are vertical. That's the converse. I have to decide if that's true or not. So let's see. Here are two equal angles. They're both 90 degrees. Are they vertical? These are not vertical angles. They're not adjusted. So this is false. And I created a counterexample here. These are two equal angles. They're definitely not vertical. Here I started off with vertical angles, and they are always congruent. Anytime you have vertical angles, they are congruent. So you cannot write a biconditional here, because while the statement is true, its converse is false. To be able to write a biconditional, statement and the converse have to both be true. In part B, if M is the midpoint of segment AB, then AM is equal to MB. So here's the segment, here's AB. If M is the midpoint, then is it true that these parts are equal? Yes, that's true. So that's true forwards. Let's talk about the converse. If AM is congruent to MB, does that automatically mean that M is the midpoint? Well, let's see. Here's AM. Ooh, that was a terrible spot. And let's pretend that AM is equal to MB. Does that mean that M is the midpoint? Does that mean that M is the point in the middle? Yes, that's also true. So this is true forwards and backwards. So yes, we can write a biconditional. So I ran out of room, so here's our biconditional. M is the midpoint of a segment. Of AB if and only if, those are the key words when you're writing a biconditional, AM is congruent to MB. Number 10, I'm supposed to decide if the conditional, so rewrite the conditional statement. Here's the conditional, and determine its truth value. Two angles are a linear pair, so a linear pair looks like this again. They are supplementary. They add up to 180 degrees. That's true. Then I have to decide if the converse is true or false. So I have to write the converse first. So converse is if two angles are supplementary, then they are linear pairs. Let's see. So let me draw two supplementary angles. This is 100 degrees. This is 80 degrees. These are not linear pairs. They're not stuck together. A linear pair needs to be stuck together to form a straight line. So this converse is false. The inverse would say if two angles are not linear pairs, then they are not supplementary. So again, using the same example, here are two angles that are not linear pairs, but they are supplementary. They add up to 180. So this inverse is false. And the contrapositive is if two angles are not supplementary, then they are not linear pairs. So if you have two angles, here's 100, I can't make these supplementary. Here's 80, or sorry, not 80, 50. Those can't be linear pairs, even if I join them together. So this is a 90 degree angle. Let's pretend that's 90 degrees. And this is 40. Those aren't supplementary. Okay? But they can't be linear pairs. So this is true. In 11, I'm supposed to rewrite the definition to be more complete. So there's something wrong with these definitions. So in 11a, a line is the object that extends in only one direction. That's not right. A line extends in two different directions, just like that. So a line is an object that extends in two opposite directions. A segment is a portion of a line. That's true, but here's what a segment is. It's a part of a line, a portion of a line, but it has two endpoints, because a ray is also a portion of a line. This is a ray. It has a portion, it's a portion of a line, but it has only one endpoint. So we need a segment. So a segment is a portion of the line with two endpoints. Part C is saying a segment bisector is a point that divides a segment into two equal parts. So that's what's saying. So this definition is only saying points can be the only type of things that bisect segments, which is untrue. You can have a ray be the thing that bisects the segment, or you can have a whole line be the thing that bisects the segment. It doesn't matter. So that's how that's incomplete. It's not just restricted to a point. A segment bisector is a point, ray, or line, pretty much anything that divides a segment into two equal parts. And in number 12, we're supposed to fill out this. We are given that AC is equal to 15 and ABC are collinear, meaning they form a straight line. In the end, we're supposed to prove that BC is equal to 12. Okay. So AC is equal to 15. Well, let me start with this. Let me start with the segment addition postulate. These are segments. I know that if I take whatever AB is, and if I add whatever BC is, it should equal the whole length of AC. So that's the segment addition postulate. I'm adding segments, adding two smaller segments, and forming the whole one. Okay. Well, and then I notice, oh, AB is equal to X, BC is equal to 4X, and AC is equal to 15 from what it was given. So I'm taking and I'm substituting these parts into their spots. So I'm using substitution there. Okay, next I can combine these like terms to be 5x equals 15. I like to write combining like terms. The book likes to write simplify. Either way, it'll be alright. And the next step to solve for x would be divide both sides by 5, so that you get x equals 3. Remember that you write the property after you do it. So I divide both sides by 5, x equals 3 from the division property. But I need to find BC. I need to show that BC is equal to 12. Well, BC was equal to 4x. And so that's 4 times 3, which is 12. And the main thing I used there was substitution. I substituted x equals 3. So there it is.